Okay, so now we're going to move on to question 3. Question 3 is non-calculator. It starts by saying the function f is differential on the closed interval -6 to 5 and satisfies f of -2 equals 7. The graph of the derivative of f consists of a semicircle, 3 line segments, as shown in the figure above. Question A asks for find the values of f of -6 and f of 5. So first we know that this is what it looks like, obviously, and we know that f of -2 equals 7. So we're going to build off of f of -2 equals 7. Personally, I think of this as kind of like a velocity versus position graph. I think that this is a velocity graph since this is the derivative, and we're looking to find the position. So we already know the first point. The position at -2 is 7. So what we're going to do is we're going to build off of that. So, for example, for f of 5, we're going to start with f of -2, which is 7, and then we're going to add on the integral from -2 to 5 of the inverse of x. The derivative of x. This will calculate the change, like the amount the function itself has changed through -2 to 5, which will give you the exact value for f of 5 by because if you start with -2 and then you add the changes, you'll get f of 5. So that's exactly what I did. So you know that f of -2 is 7, and then this was stated in there that it's a semicircle, so you have to subtract you have to add -1/2 pi times 2 squared, and then you also add the triangle with base 3 and height 2, so it's just that. So you get 7 minus 2 pi plus 3, so f of 5 therefore will have to be 10 minus 2 pi. Now we have to go to f of -6, which is a little bit more tricky. So we're going back from our basic knowledge that f of -2 is 7. But this time we're going to have to go backwards. We're going to have to find f of -2, and then we're going to have to add the integral from -2 to -6 to calculate that change. But as you can see, that's not the right order, as to usually go from the lesser number to the greater number. So instead what I did was I just subtracted it and then flipped the thing to make it easier for myself. And then you can just make this a triangle, and the area of the triangle with base 4 and height 2 equals 4, so it's 7 minus 4, which is 3. So the answers for part A, is f of 5 equals 10 minus 2 pi, and f of -6 equals 3. Now B asks, on what intervals is f increasing? Justify your answer. This may seem hard, but basically the interval at which f is increasing is when the derivative of f is positive. So this is the graph of the derivative, f shown over here. And basically whenever the graph is above the x-axis or is positive, that's when it's increasing. So the intervals at which the f is increasing is -6 to -2 because it's positive, and 2 to 5, again because it's positive. I also helped you out by making a sign chart. You can just see that they're both positive. Alright, so now C asks, find the absolute minimum value of f on the closed interval -6 to 5. Justify your answer. So first I want to start by finding what are the possible values of the minimum values. So we know that through prior knowledge, we know that there must be a minimum value on a function from interval a to b, and it can either be the endpoints or it could be in the middle. So we know that -6 and 5 are possibilities for being the absolute minimum value, and then the critical points at which there's 0 could also be. So -6, -2, 2, and 5 are all possible points that are the minimum values. Now, as you can see, those are our possible points. From A, we already know that f of -6 is 3, f of -2 is 7, and f of 5 is 10 minus 2 pi. So all we have to do is find f of 2. And we can use the same exact method we used in A. So we started with -2, and we're just moving all the way to there, calculating what happened, the change in there, and adding it to 7. So you just use the semicircle, so it's 7 plus, or well, in this case it would be minus 1/2 pi times 2 squared, and you just get 7 minus 2 pi. And since f of 2 is 7 minus 2 pi in relation to all these, this is the lowest number. So therefore, the absolute minimum value of f on the closed interval, -6 to 5, is when x is equal to 2. So D asks for each of f, the second derivative of f of 5, and the second derivative of f of 3, find the value or explain why it does not exist. So we're going to start with f of -5. So f of -5, as you can see, if we're trying to find the second derivative, all you have to do is you have to find the line tangent to this, because that equates to the slope of the graph. So basically what I just did was rise over run. 2 minus 0, because it's 2, 0, over -6 minus -2. And you get -1/2. So basically the second derivative of -5 is the tangent to this line, which is -1/2. So yeah, that's the second derivative. However, for f of 3, it's a little bit of a different case. It does not exist. Now, there are 2 ways to do it. Personally, the first way I prefer better. As you can see in the graph, there's a very distinct, drastic change from the left side as opposed to the right side. It's not gradual, so it's not differentiable, so you can't, it's a cusp. You can't find the second derivative of that. Also, another way you can do it is that you can find, so this is the limit, y1 minus y2 over x1 minus x2. And so the limit as this line approaches 3, as x approaches 3 from this side, the left side, actually equals 2. I made the triangle, I did rise over run for both, it equals 2. And on this side, as x approaches 3 from the positive side, it's approaching, or the slope itself is -1. And since that is not equal to that, it's not differentiable, so it does not exist. And that's the answer for question 3.